to imagine model. So normally I would only ask you to go up to the third nearest neighbor. Okay, of course I can ask you to find up to 4th, 5th, 6th nearest neighbor, but because it's very hard for us to visualize, so I will only ask you to get for the first 3, and for the first 3 I think it's not that difficult. It's quite okay, still okay, quite easy. Okay, so now we can conclude that, let's say if I take this as a sodium plus ion, then there will be 6 chlorine ion at the distance of R0, and 12 sodium ion at the distance of square root of 2r, and 8 chlorine ion at distance of square root of 3r. So now we want to find the total Coulomb attraction energy, okay, due to each ion pair. So we can summarize it in the infinite series. Okay, so you get E equal to negative E squared over 4 pi epsilon naught R 1 plus negative E squared over 4 pi epsilon naught R2 plus negative E squared over 4 pi epsilon naught R3. And then you rearrange it, you get this format. You get this format. Okay, so for the first term, there will be 6 ion at R0. Okay, so the second term will be 12 Na at square root of 2 R. The first one is 1R, so here is 1 over 1. The second term is square root of 2R, so it's over square root of 2. The third term will be how many? The number is 8, then over square root of 3. Okay, and that's one thing that you need to bear in mind, that for Na and Cl, here is positive. Na and L, Na and Na, here will be negative because they have same charges. Na and Cl, positive. And the fourth one, if Na and Na, then they will be negative. Okay, then now you just solve this one. Okay, so of course this E will be the charge of an electron, is 1.6 times 10 power negative 19. Okay, and 4 point epsilon naught is equal to this value. Okay, or if you don't believe, then you just substitute the epsilon naught there and then times pi times 4, then you get this answer. So I can say that this term, I can refer this term, we write as alpha, and this alpha is referring to the Madelung constant. Okay, if I ask you to calculate the Madelung constant, then you just need to solve this part. Okay, if I ask you to calculate the Madelung energy, then you need to solve the whole equation. Okay, so this is the difference. So here I give you some example value of the Madelung constant. For sodium chloride, the Madelung constant 1.747565. So this alpha equal to 1.7475. For cesium chloride, the Madelung constant is 1.7626. For cubic zinc sulfide, the Madelung constant is 1.638. However, for the woodside zinc sulfide, the Madelung constant 1.641. And then for the copper oxide, the Madelung constant 4.115. So you need to take note on this part, that zinc sulfide, both are zinc sulfide, but when the atom of the zinc sulfide arranged in the different atom arrangement, then you will get the different Madelung constant. When I get the different Madelung constant, you get different Madelung energy. When you have different Madelung energy, that means that you also receive different cohesive energy. Different cohesive energy means that it will have different melting point. Therefore, the atom arrangement in the solid is affecting the thermal property of the particular solid. Okay, so the atom arrangement is important in melting point as well as the thermal properties such as the static heat, the thermal conductivity, and so on and so on. Okay, I will explain this in the next chapter. Phonon. Phonon is a lattice vibration. So the property of the ionic crystal depends on the charge transfer because it's always involved the charge transfer from sodium to chlorine. Sodium donate one electron, it transfer one negative charge to chlorine. Therefore, the sodium become positive charge and the sodium become negative charge. The strength of the ionic binding is high as compared to other type of the binding. Therefore, the ionic compound normally have high melting point. So the binding strength of sodium chloride and potassium chloride are 7.9 and 7.3 electron volt per molecule respectively. Okay, so this is the first type of the binding, the ionic binding. And the second type of the covalent binding, the second type of the chemical binding is a covalent binding. All right, the covalent binding sometimes we call it valence binding. Okay, so this is a binding of a pair of electrons whereby two atoms sharing two electrons.